Hello, good morning or afternoon, everyone. It's a pleasure to be here today. My name is Denny, and together with my team, Narendra, we are excited to present our research titled Comparative Analysis of BERT and CRF/Spacy Algorithm for Resume Parsing. We conducted the study as an undergraduate student of the Computer Science Department at Bilan Nusantara University under the guidance of our lecturer. Our research focused on enhancing the efficiency of recruitment process through automated resume parsing. Automated resume parsing has become an essential component of the modern recruitment process, enabling an organization to efficiently process unstructured data from various file formats. This research evaluated the performance of two NLP algorithms, BERT and CRF/Spacy, in the task of resume parsing. The study employs experimental, comparative, and quantitative approaches, analyzing key metrics such as F1 score, precision, recall, and processing time using dataset in PDF, doc, and HTML formats. The results indicate that BERT achieved high accuracy with F1 score of 0.95, making it suitable for large organizations that require advanced analysis of complex data. Conversely, CRF/Spacy demonstrate faster processing times, making it ideal for small to medium-sized enterprises that prioritize real-time results. In today's technological era, automating resume parsing analysis has become a very important aspect for companies to manage job applicant data efficiently. Resume parsing involves converting unstructured data into structured format, which allow recruiters to streamline the decision-making process efficiently. Despite this capability, challenges arise due to the diverse format of resumes, both structured and unstructured. To overcome this, a natural language processing NLP algorithm is needed that can adapt to varying level of complexity among the popular NLP algorithms. BERT has shown outstanding performance in handling name entity recognition (AKNR) tasks due to its bidirectional contextual understanding, making it suitable for unstructured data. In contrast, CRF/Spacy provides computational efficiency and excels in processing structured data. However, previous studies have only focused on these two algorithms separately and without direct comparison in the context of resume parsing. This study aims to compare BERT and CRF/Spacy algorithm in the context of resume parsing, focusing on accuracy, time efficiency, and adaptability to various resume formats. The objective of the study is to assess the precision of BERT and CRF/Spacy in analyzing applicant resume and compressing personal information, job titles, skills, and work experience. Additionally, this study aims to compare the efficiency of BERT and CRF/Spacy in processing datasets of varying size. Furthermore, the study identifies and analyzes the capacity of the two algorithms to process resume in PDF file format, including both structured and unstructured content. The findings of the study are expected to identify the strengths and weaknesses of BERT and CRF/Spacy algorithm and to provide recommendations and suggestions to the HR professionals or recruitment system developer for implementing this algorithm in the resume parsing system. These recommendations are based on the result and performance analysis of this research. Number one, natural language processing, aka NLP. NLP is a branch of artificial intelligence and computer science focused on enabling machines to understand, interpret, and generate human language. Its application range from text categorization and translation to chatbots and resume parsing. NLP play a critical role in building automated recruitment system by extracting structured information such as skills and experience from unstructured text. And number two, resume parsing. Resume parsing involves extracting and normalizing and classifying information from various file formats such as PDF, doc, and HTML. The process includes extracting text from resume to ensure compatibility across format, and categorizing data into sections such as education, work experience, and skill using name entity recognition. And number three, normalizing data to standardized format and facilitate efficient search and analysis. BERT, bidirectional encoder representation from transformer, is a deep learning model designed for language comprehension text. Its bidirectional architecture enables it to analyze complex word relationships, making it highly effective for their tasks. This capability is particularly useful for identifying entities like names, job title, and skill even in structured format like PDF and doc files. However, BERT high computational demands make it less suitable for real-time application. It is most effective in industry that require high precision and accuracy in candidate selection. Conditional random fields, aka CRF, are probabilistic graphical models widely used in NLP for sequence labeling tasks such as NER and part-of-speech tagging. CRF is efficient in handling structured data and when integrated with Spacy, produce well-structured output. While CRF is suitable for structured resume template, its reliance on predefined feature engineering limit its adaptability to unstructured data. Despite this, CRF lower computational demand make it ideal for environment with limited resource or real-time processing needs.
Research methodology. The first one, we have data collection. The second one, we have methods and tool use. Third one, we have performance measurement. Fourth one, we have experimental methods. And five, diagram method or flow method. In this study, we use experimental, comparative, and quantitative approaches to evaluate the performance of BERT and Spacy, CRF/Spacy in a resume decoding task. The first one, experimental approach. This approach evaluates algorithm performance for specific tasks using controlled data to ensure accurate comparisons. Experiments were conducted on a dataset in PDF format to compare accuracy, processing efficiency, and the ability to handle various resume formats. PyPDF2 was used to extract content from PDF files to ensure compatibility. The dataset included essential elements such as personal information, work experience, and skills, and was designed to cover various formats such as PDF and HTML to support model generalization. 2. comparative approach. In this approach, we compare the performance of BERT and CRF or Spacy algorithms using metrics such as F1 score, precision, recall, and processing time. It aims to provide practical recommendations for companies or organizations in choosing a resume parsing system that suits their needs. And 3, quantitative approach. Quantitative data is used to analyze the result of experiments. We measure the performance of algorithm based on evaluation metrics such as accuracy and efficiency to provide strong foundation for comparing the effectiveness of BERT and CRF/Spacy in the resume parsing task. In overview methods, the research utilized BERT and CRF/Spacy for resume parsing due to BERT ability to deeply understand context in unstructured data and CRF/Spacy efficiency in sequential labeling for structured data. These algorithms were chosen to address diverse parsing scenarios in recruitment systems. An experimental approach was employed to evaluate their performance in terms of accuracy, time efficiency, and capability to handle data in various formats. In dataset, the study used a dataset of 2,000 resumes across 24 job categories to test the algorithm under controlled condition. The resume were manually labeled for elements like personal information, work experience, skills, education, and certifications, with non-choice based on predefined categories. The dataset included diverse formats such as PDF and doc. In tools and software, the implementation of BERT utilized the transformer library from Hugging Face for its flexibility with transformer model and compatibility with PyTorch and TensorFlow. Pre-trained BERT models were employed for deep contextual understanding, supported by tools to enhance model training and inference. For the CRF algorithm, the Spacy library was integrated to handle sequential labeling tasks efficiently, focusing on the structured data and computational speed. Additionally, PyPDF2 was used to extract text from PDF resumes, ensuring compatibility with diverse files formats sourced from Kaggle, the diagram method or flow method. In making this research, we make a plan that is carried out in the order of the workflow diagram, where we search for datasets after determining the topic that has been determined together and is suitable to the support development of the model we make. After finding defined and a suitable dataset, we extracted the data from the source found to be ready for use and then filtered dataset to ensure that only the data that we wanted was high quality. The next step, we tried to analyze the dataset to understand the structure of the data that was relevant. After completing the dataset, we started to develop the model using BERT and CRF or Spacy and started using Google Colab. In model building, we inserted the analyzed dataset into each model for testing and testing. After successfully coding, we extracted the results of each model, such as the performance of the model, and analyzed the results model's performance based on the F1 score metric, which measures the balance between precision and recall. As well as we tried to calculate the performance time using stopwatch, how long does the model took to show the results. After completing the performance results, we evaluated the results of the analysis necessary to determine the best model performance or the necessary improvements. Presentation of result. The table shows that BERT achieved a higher results in F1 score, precision, and recall compared to CRF or Spacy. This indicates that BERT is able to effectively handle unstructured data, but in terms of processing speed, it takes longer than CRF or Spacy, making it less efficient for real-time applications. Processing time was measured using a timer to assess the efficiency of each algorithm, and it was determined that it took 88,200 milliseconds of processing time for the BERT model, whereas it took 1 minute 47 seconds or 88,200 milliseconds for CRF or Spacy from 25 resume data. In contrast, CRF or Spacy, although lacking in precision, was able to process faster, required less computing resources, and the processing time required by CRF or Spacy was only 1 minute 24 seconds or 74,400 milliseconds. This makes a good choice for structured data processing or having limited resource. Moving on to the next one, experimental methods. Each algorithm is applied to a dataset that already has labels, and the results are analyzed using predefined performance metrics. This method ensures consistency and repeatable results that help in assessing the effectiveness of each algorithm in summarization extraction task. These methods uses 25 examples of datasets and is tested on each model, BERT and CRF/Spacy. The difference on each model creates a different output. Result of analysis, accuracy. BERT consistently outperforms CRF or Spacy in terms of F1 score, precision, and recall, demonstrating its superior capability in resume parsing. BERT achieved an F1 score of 0.95, reflecting its high accuracy in identifying complex entities. Its ability to understand bidirectional context further enhances its performance in parsing unstructured resumes. On the other hand, CRF or Spacy, while yielding a lower accuracy of 0.78, offers a faster processing time, making it better suited for speed-critical real-time application, where computational efficiency is prioritized over absolute accuracy. The next one, processing speed. CRF or Spacy shows a faster processing time in completing tasks, which is about 74,400 milliseconds compared to BERT, which reaches 88,200 milliseconds. BERT's slower processing time speed comes from its complex transformer architecture, which needs more computing power than CRF's simple design. This shows that CRF or Spacy is more efficient for those who prioritize speed in managing resumes. And the last one, handling different formats. BERT shows excellent adaptability in both structured and unstructured resumes, whereas CRF or Spacy is more suitable for unstructured data as it relies on predefined rules and patterns. These results emphasize the trade-off between accuracy and computational efficiency in selecting algorithm for resume parsing. And moving on to the conclusion, this study concludes that BERT is best suited for applicants requiring high accuracy, while CRF or Spacy excels in real-time processing due to its efficiency. BERT achieved a superior F1 score of 0.95, reflecting its accuracy in parsing complex and unstructured data from resume formats. In comparison, CRF/PC with an F1 score of 0.78 offer a faster processing time, making it really ideal for speed-critical tasks. The research highlights the strengths and limitation of both algorithms, emphasizing their respective advantages in accuracy and speed. A combination of BERT and CRF or Spacy propose an optimal solution for resume parsing, tailored to the specific needs, companies, and organizations. Furthermore, the study suggests that a hybrid approach could enhance both efficiency and accuracy in further application. This research provides practical insights for organizations aiming to implement automated resume analysis system. It is expected to improve recruitment process by balancing speed and precision for handling diverse unstructured resumes format. BERT is the recommend for its deep contextual understanding. Meanwhile, CRF or Spacy is more suitable for structured and high-speed tasks. Thank you for your attention and interest of our research. We believe the study contributes valuable insight to enhancing recruitment automated processes. We are happy to answer any questions or discuss the further findings. See you guys. Thank you.